So hyperbolas, here are the formulas. If you'll notice, I said they look a lot like ellipses. What's the only difference between the hyperbola formula and the ellipse formula?
It's minus.
Minus. So when you see subtraction, you're going to have hyperbola. Same kind of ideas. You have the centers the same, HK. Under the x is an a squared. Under the y is a b squared in the first one. And they switch in the second one. Notice the second equation, y squared is first. The a squared in hyperbolas is always first. It is not necessarily the biggest. Ellipses, it has to be the biggest. In hyperbola, it's just first. It's not always the biggest number now. Okay, the a squared is just first. If it's an x squared minus a y squared, you have a horizontal hyperbola. It's opening side to side. If the y squared is first and it's subtracting the x squared, then you have an up and down hyperbola. So that's how you can tell the difference between the two graphs. You have asymptotes that are guiding the width of this hyperbola. And so that's the asymptote equation. Y equals plus or minus m, the slope, times x minus h plus k. So the h of the center is opposite, but the k is just sitting there. The slope, I call it the y radius over the x radius, or the vertical move over the horizontal move. So we'll talk about that when we get to an example, and you'll see what I mean by that. Okay? A lot of the stuff is the same. But A doesn't have to be the biggest. B could be bigger than A. C is bigger than either of those. My focal points are out here, past the A distance. So this is A, this is now C. So when we're doing the Pythagorean theorem today with hyperbolas, it's back to the a squared plus b squared equals c squared. So that Pythagorean theorem is still a little bit different from yesterday. Yesterday, it was b squared plus c squared equals a squared. We're back to the usual now. Okay. You ready? Try one? We're just going to jump in. I'm going to skip the easy one. We're jumping straight to the heart. Okay. So what's the center? Just like yesterday, what is the center? -2, 5, right? The x comes from the x. The y comes from the y. Parenthesis. Okay. Under the x, we have 9. So I'm going to go right and left. How many? 3. My a value is 3. Yes?
Sure, your a value is the smallest.
A value is the first. Nothing to do with size with hyperbolas. It's just the first guy. So over here, we're going up and down how much? 7. And again, it really doesn't matter A or B. Just know that A is always first. Okay? So if I am at the center, -2, 5, to graph this hyperbola, I'm going to go right and left 3, up and down 7, and here is where we would draw the ellipse, but it's not an ellipse, it's a hyperbola. So what you're going to do is very faintly, nice thin line, you're going to draw a rectangle where those points are the midpoints of the sides. And then again, very lightly, you're going to draw the diagonals of that rectangle. These are your asymptotes. So the rectangle is just helping you find where your asymptotes are. So you're going to draw a rectangle, a box. Then you're going to draw the diagonals of the box are the asymptotes. Now, it is x squared minus y squared. So it's a hyperbola that's opening left to right. Left and right. So these are the vertices. So it's going to come down the asymptote. It's going to hit there. So it should never go into the box. Your vertices are right here. So it comes through the asymptote and cuts out like that. It's a very wide hyperbola. Okay. So if I wanted to figure out where my vertices are, there's my center. My vertices are right and left because my parabola or my hyperbola is opening right and left. So we're going to add the 3 to the x, just like we did yesterday with the ellipse. And we're going to subtract 3 from the x, part of that center. Those are our vertices. Those are these guys right here. If you looked on your graph, you can kind of just see them. If I want to find my focal points are somewhere in the curve. They're out here somewhere, out here somewhere. So I have to find my c value. So a squared plus b squared equals c squared. Well, my a and b are just sitting there. 9 plus 49 is c squared. C squared is 58. So c is the square root of 58. So 7.5, whatever. So again, I'm at my center. I'm going to add, I'm going to the right. I'm going to add the square root of 58 to the x. So you're just going to leave it like that. Negative 2 plus the square root of 58, comma 5. And I'm going to subtract the square root of 58 from the x. And again, the y doesn't change. Your vertices and your focal points are on the same axis. You're going horizontally there. No. What variable comes first? X. So if it was a y squared minus x squared, you'd be adding and subtracting from the y, because you'd be going up and down. So the variable that comes first creates what's called the transverse axis. So this is the transverse axis here. So instead of calling it a major axis, we call it a transverse axis with hyperbolas. The minor axis is called the conjugate axis. Has nothing to do with size, though. Transverse means that's the axis that we're opening on.
How will you know what comes first? When you're given the set of numbers?
We're going to talk. Okay? If they mention transverse axis, or you know how we could tell which one was bigger yesterday with ellipses? The focal points are going along the transverse axis, the vertices are the transverse axis, so you can tell what's changing. They give you points, okay? All right, the only thing we haven't talked about is the asymptote. And again, the asymptote is not hard to write here. We're going to write it in red. So it's y equals plus or minus. What did we say the slope was? Rise over run. So we went up and down 7 over the run was 3. And then you do x minus the h of the center, and then the k is just sitting out there. So that's why I always write, what am I doing left to right, what am I doing up and down, so it's sitting there for me. I want the rise over the run for my asymptotes. Okay? So if I were to ask, if this was an ellipse, I would say one of the axes is 6 units and one of the axes is 14. Since it's not, it's a hyperbola, we would say the transverse axis is 6 units long, the conjugate axis is 14 units long. So it's the same as with the ellipse when we talked about major and minor, where we're using the words transverse and conjugate. Okay? Let's try another. All right? Figure it out. There's the answer, kids. Okay, move on. So, I have a hyperbola with focal points or foci at 0, -3, and 0, 3. So remember yesterday when they gave you focal points, the middle is the center, right? The midpoint? So what's the midpoint of those two focal points? 0, 0. So there's my center. What else was I able to tell from focal points? What letter is it, A, B, or C, that you can get from focal points? Which letter relates to focal points? C. So what is my C value? How far apart is the 0, 0 from one of those points? 3 units. What else can I tell from focal points? How are my focal points moving, horizontally or vertically? Vertically. So it's a vertical hyperbola. So my y squared is first, right? Because it does this. So I can get all of that stuff from just those 2 points. And then they tell you the conjugate. Conjugate relates to B value. The conjugate length is 4, so what's B? 2. So I have a B and I have a C. I need an A. So A squared plus B squared equals C squared. So A squared equals 5. So I can write my equation. We are starting with y squared. We're not subtracting anything, so these are just basic y squared minus x squared. My A squared is always first. My B squared is second. It does not matter which one's biggest. A is always first in a hyperbola. And you're done. Easy enough? If I wanted to be crazy and ask you for the asymptotes. Y equals plus or minus. What would the vertical movement be? I would be going up and down the square root of 5. Can I break that down? No, just leave it like that. What's the horizontal movement? I'm going to go right and left. How many? 2. And there's nothing to subtract. The center is 0, 0. Okay? All right. Let's try another one. See what you can get. Everyone understand this is the midpoint. What number is right in between here? So we would do -2 plus 8 divided by 2. -1 plus -1 is still going to be -1 when you divide by 2. Okay? They told me those were the endpoints of the transverse axis. So those are the vertices. So what letter goes with the transverse axis? A, B, or C? A. So how big is A? From the center to one of those endpoints would be 5 units. The total axis is 10. Okay? Which way am I going with my hyperbola? Left to right or up and down? Left to right, because my endpoints, my x's are changing. So we have an x squared minus a y squared. Then they tell me that the conjugate axis is 8. Conjugate relates to the B value. If it's 8 total, it's going to be a 4 for B. You already have your A, you have your B, you have your center, you can write your equation. You don't have to find the focal points to write the equation. So it's going to be x minus 3 squared minus y plus 1 squared, bless you. And then A squared always goes first. All right? You feel good? You need to figure out, are we looking at an A, a B, or a C? What's my center? Which way am I going? Okay? Do we want to do one more like that, or we just want to continue? Okay, we will skip this per 6 periods request. All right, now I'm giving you asymptotes. And I also told you the vertical transverse axis. So if it's a vertical transverse axis, what comes first? Y. All right. So looking at this asymptote, what is my center? What's the center point? Remember, it's if you pull out of the x parenthesis, it's opposite. If the y part is not in parentheses, it's just going to be that number. Okay? So I can put those guys in here. All right? What was my vertical move? 4. So I would square that. My horizontal move is 3. So I'm going to square that. There's more than one answer to this because it could have been 4/3 reduced. It might have been 8/6. In which case that would be 64 and 36, right? So there could be other possibilities there. That could have reduced something to 4/3. Because it told you there was a vertical transverse axis. Okay, vertical transverse axis. Right? Okay, one more example and we're done. Can we do it?
Yes.
Okay. Here we go. We're going to complete the square just like we did yesterday with ellipses. Same process. You're going to gather up your y's together. Guys, whatever is positive, put first. Don't rearrange them so the x is first. Bless you. You want the positive variable first, then the other variable stuff, and then the number to the other side. Okay, so we're grouping again. And then we're going to factor out that little coefficient from each squared term. So this guy's going to be 25. Y squared minus 2y plus a blank. Hang out there for a second. With an ellipse, you have a negative, so you're going to factor out a negative 9. So when you factor out a negative, remember it changes that sign in the middle there. Okay. So what would I add to the first parenthesis? Half of 2 squared is 1. What would I add to the other side? 25. Second parenthesis, half of 6 squared is 9. What's going on the other side? Negative 81. So in hyperbole, you're going to add and subtract to the other side. Okay, so writing this in binomial squared terms, you get y minus 2, or I'm sorry, y minus 1 squared minus 9 times x plus 3 squared equals 225. What's that noise again? Sunday that went on for half the time we were here. It was annoying. Okay, what's our last step? No, it's more than the shutter thing. It was a constant. It wasn't coming from, I don't know where it was coming from. It was weird. Very weird. Normally it's the shutter thing, but that's... Okay? A lot of the same processes. Some little slight things that are different. You got to factor out that negative. You got to make sure your inside flips. So tomorrow is a work day. I